Okay, so I said I wanted to finish the notes from 2.2 because we're going to start 2.3 on Wednesday. And so the intermediate value theorem is what we needed to finish, or IVT. And this says if A and F of A, okay, so that's 1 point, and B and F of B, that's another point, are 2 points on the graph of a polynomial function such that F of A does not equal F of B, then for any number, let's call it D, between F of A and F of B, there must be an X number value, call it C, between A and B, such that F of C equals D. Okay, so keep in mind here what's our domain, what's our inputs, and what's our outputs. Our input is C, right? Because remember, that's our input there. And our output is D, right? And so graphically, I want to draw. So this isn't, let me see if I can make a semi-straight line. That's not too bad. I want to draw what is being represented by this theorem. Okay, so what it says is this: if we have, let's say A here, actually before I do that, let's draw some graph. Let me draw some function. Okay, I'm gonna draw some I'll draw something like that. Okay, some polynomial function there, and let's call this A and this B. And we are on, this is X and this is F of X, right? Which is the same as Y, right? That's our Y axis. And so this right here is F of A and this is F of B, okay? And so what this theorem tells us is if we have a point, so there's our point, there's our point there, A, F of A, right? And that's B, F of B, where we can clearly see that F of A does not equal F of B, right? We clearly see that these are representing two different values on our function. So this tells us is that if this is true for any graph of a polynomial function, then, let's see, I'll use purple, then there exists some C between A and B, because remember, all polynomial functions are continuous everywhere, right? So we don't have to worry about holes or jumps or gaps because we're talking about a polynomial function. So if that's the case, then there's some C value such that that's between A and B, such that F of C, right, which we're calling D, is going to be between F of A and F of B. Okay, so it makes sense, right? It's pretty straightforward, this theorem. Now let's see how to actually apply it to what we've been talking about in our class. Okay, so note that the IVT, the intermediate value theorem, helps you locate, it actually can help you locate the real zeros of a polynomial function in the following way, okay? And this is how it's going to be helpful to us. If we can find a value, let's say X equals A, at which a polynomial is positive, so its output is positive, so F of A is positive, and another value, let's say B, that's negative, then for any since we know polynomial functions are continuous, that tells us that we can conclude that a function has at least one real zero between those two values, okay? So hopefully that makes sense, because if we go back here, this wasn't necessarily the case, but remember, the zeros represent what? It's our x-intercepts, right? And so what's happening is this. Let's say we had a value here. We can call this A, and let's say, let me use a different color. Let's say B is over here, right? Okay, so this is F of A. I don't know if you guys can see that yellow. That's not really a good color to mark up. Let's go back to black. Okay, so this is F of A right here, right? And then this is f of b. Now we can clearly see, and we're going to do an example. We're going to finish example 4, but I wanted to show you graphically what we're saying. We're saying that if x equals a, right, and let's say this is -1, and let's say that's +1, right? And let's say, yeah, let's put some values here. And actually, let me do it again. I feel like this graph is getting a little messy. So let me do something brand new. Okay. All right. So let's look again at this graph. And let's say, let's call this, let's say that's the number 1. And that's -1. And let's say this is, let's call that 4. And let's say that's 2. Okay. So here's what the intermediate value theorem is saying, and I don't think I've tried this I've talked about it, but never given a real example to look at. So hopefully this will be helpful for you all to understand what this theorem is saying. So we see that, this is -1. So we see that f of -1 is -1, right? And then, now it doesn't, let me make sure, I want to make sure you're clear. This input doesn't have to be negative, right? You're really, for the intermediate value theorem to make this useful, you're really looking at your output. So you're saying f of -1 is negative, and then f of 4, we're looking at, again, at the output is positive. So that means that in order for this, because it's a polynomial function, because it's continuous everywhere, then that means somewhere between -1 and 4, a 0 exists, or an x-intercept exists. And as we can see from this graph, it does, right? We see that our graph, wish this was Notability. I can't use Notability for my videos, but I wish. Anyways, but we can see from our graph that there's an x-intercept, or a 0, right there. So that's the use of the intermediate value theorem, because we know that not only does there have to be a value in between, 2 of your values that you pick, but if you've shown that between this interval, so we're looking, in this case, we're looking at the interval -1, 4, because again, we're talking about on our x-axis. So between -1 and 4, since f of -1 was negative and f of 4 was positive, that means a 0 exists somewhere between -1 and 4. And the beauty of this theorem is to guarantee that a 0 exists, because sometimes, especially in real world applications, you may not be able to find that x value. It might be very difficult. You might have some complicated polynomial and it's difficult to find the 0 of your function. But as long as you can estimate, and we won't have time to get into that, how to estimate, you'll learn that in calc, or we might have time if I get a chance to come back to it, but you can estimate what that 0 will be. And so for us, looking at this graph, I would say, what's a good estimate of that x value? I would say a good estimate would be it's not quite -0.5, but it's a little smaller than that. So you can estimate maybe -0.4 or -0.3 would be a good estimate. Okay. So I hope that makes sense. I want you to really understand this theorem. Okay. Now let's look at it without needing a graph, without using a graph. So it says use the intermediate value theorem to estimate an interval that contains a real 0 for the function f of x equals x cubed minus x squared plus 1. Okay. Here's where it's trial and error. Okay. You're basically looking for an x value that's going to give you a positive output, and then one that's going to give you a negative, and then there's your interval. Okay, so it's really trial and error. Guessing is a mathematical technique, and so I usually start with 0 to see what my output is at 0. So if I plug in 0, we'll get 1, right? We get positive. So that means we're looking for a negative output, right? And then when we get a negative output, we look at the x values to see what our interval is, okay? Well, what if we try 1? We plug in 1, and wherever I see 1, so that's 1 cubed minus 1 squared plus 1, so that's 1. That's positive, so that's not helpful. Well, what if I try a negative 1, okay? And again, it's not necessarily a rhyme or reason. You might want to start off with 0, 1, and negative 1 just because those are easy values to compute. But you're looking for an output. Now we found an output that was positive. We actually found 2 that were positive, right? But so this interval is not going to be unique. It could vary from student to student. You all may not have the same interval, okay? What about negative 1? So that's negative 1 cubed minus negative 1 squared. I always like to use parentheses when a negative is involved. So that's negative 1 minus 1 plus 1. What's that? Negative 2 plus 1. Voila. We have a negative output, right? So we have a positive and negative output. So the question is, well, what's an interval, a possible interval where that contains a 0? So you would need to show me that you found an x value that gives you a positive output, an x value that gives you a negative output, and then the interval would be between those 2 values. And again, remember when you're writing in interval notation, it's smallest to largest. So a possible interval would be negative 1 to 0. But we also found that f of 1 gave us a positive output as well, right? So you could have also stated negative 1 to 1. Okay. And so hopefully that makes sense. If you have any questions, please ask on our next class meeting. But this is the intermediate value theorem.